Hello everybody, how's it going? So, still in the preparation for working on the kernel, well, actually working on the kernel in Anger. I want to try to see how far I can push the Zig build system and how much I can mold it to my needs for this kernel. So that's the goal for today. Let's get started. Right, so currently we have our kernel stub or our kernel placeholder, and it's just this function here called kernel entry that has an infinite while loop in it. And the way this works is that we have this linker script that says that the entry point of our executable is this kernel entry symbol. It also gives values for some other symbols, as we've seen before. And here we specify the entry point address of our executable in memory. So this linker script basically controls how our executable is laid out in memory. And linker scripts are very useful in microcontroller stuff and low-level stuff in general, because you do want to have that fine control over how things are laid in memory so that you can work around some pretty heavy memory constraints. Right, and then we have our makefile, which is basically just the recipe of how to put all these things together to build us our kernel 64.elf, which is our output. Right, so we want to have to replicate pretty much this, but in Zig. So I guess we are going to start by removing. Yeah, I don't know about the linker script. I think I'm gonna keep it. Yeah, I'm gonna keep the linker script. The makefile though would just go away, I guess. No, actually, the makefile would just become. So this would go away. This would stay. No, actually, what am I doing? I could use this simple technique. Yeah, I could use this one simple trick that doctors hate. I could go and do 64.elf, build that there. This would be kernel 64.elf, and it will go to kernel 64. Whoa, what was that? Dot elf. And same goes for this one, 64.elf. Right, so this one goes away. This one goes away too, and we are left with just this. Cool. So now I guess we can go ahead and create our Zig build system. So I guess we'll need, so it's called build.zig, so build.zig. And inside that build.zig, we want a function called build that takes a pointer to stud build and returns nothing. Right, so I guess const stud would be import stud. So we want a public function build with a lowercase b that takes a b, which is a pointer to stud build, returns nothing, and that's pretty much it. And here from memory, I think we are going to want to create a kernel exe, which would be build.io. add executable or create executable. No, I guess let's just do executable. So it's just add executable. And it takes executable options, which will give it. But what are these options? So I guess we want a name, and the name would be kernel 64. We want a target, and we will create a variable for that. We want a optimize, and we want a. So let's take a look at the other options. Version, we don't really care. Linkage, we don't care for now. Use LVM libc, we don't need that. Invite tables, error tracing. Root source file, we need that. So path is there. Yeah, so I guess path like that, and we want this to be under source and main.zig, as always. What else do we have here? So we were on omit frame pointer. I guess that's pretty much all we need. Yeah, that's pretty much all we need, I guess. So we will need to define, so target equals something, and const optimize will be also something else. So let's see what we have here. So add executable target b.host. Okay, so we did not do too bad, I guess. So I guess we are missing this install artifact. Right, so let's add that. So this would be b.install artifact, and it takes, I guess, kernel exe. Right. Right. So user provided options, we don't care about those. Standard configuration, yes, this is what we want. So it's b.standard target options and b.standard optimize option. Right. So this one here would be b.standard target options, and it takes some options here, which we will see in a bit. And this would be standard optimize option. And this also takes some options. We will check those out now. So just one option, I guess, preferred optimize mode. And what is that? Debug. Okay, so here, how do they do it? So they just pass it, right. So they just pass it a default value here, and they override it in the command line. So I guess we could just do the same, right? How about this? So we have whitelist and default target. Okay, do we have anything here about cross compilation and stuff like that? Testing, generating files, not care. Producing assets, okay. The code, one or more generated files. Yeah, I don't really care about those. Oh, multiple targets for make and release. So targets. Resolve target query. T. And they have this target query there. Right, so we might want to use that, I guess. So resolve target query. And here we'll have to pass it a target query. So yeah. So CPU architecture, what do we have there? So here we know that we want x64. CPU model, what's CPU model? I guess we don't really care about that. What's ABI? ABI we want to have none. Or do we want GNU ABI? Yeah, that's the actual question. I think we'd like GNU, but for now I'm just gonna stick with none. So what? Yeah, I'm missing that. What else do we have here? What's O format? Object format. What's object format? We want ELF. What's OS tag? Is there like none? Freestanding. Oh yeah, I've seen this. Freestanding. Cool. This is exactly what I wanted. Dynamic linker. What's dynamic linker? Okay, so it just takes a sort of path. So I don't really care about that. CPU features might want to revisit those. glibc, we don't care, we don't use that. Okay, so I guess those are the things that we are interested in. Right, so we have our target goes here. It's happy, it's not showing any errors as of yet. But there's one thing I want to do is, where do I specify our linker script? Is there like, hold on, there we go. So linkage, what's linkage? Link mode, static dynamic now. So where do I specify linker scripts? So let me search here, linker script. Set linker script path, set linker script, okay. Oh, I clicked that twice. Huh. Wait, what? Oh, so both of them point to the same function, I guess. Cool. So this is under step compile. Set linker script takes, well, the self and takes a source, which is a lazy path. Okay. So what's a compile? This kernel exe is compiled, so I guess I could do kernel exe.set linker script deprecated. Okay, so we should use this one here, and this would be path and linker.ld, I guess. Okay, cool. Right. So for now, this looks pretty good. I guess the thing that I'll need to do now is go ahead and create source main.zig. Right, and let me go back. What am I doing? Let me just remove this whole thing. Go here, create source main.zig. There we go. And I'll go over here and change this to start. Right. So const, we don't need set for now. Let's go ahead and do public function. I guess we could export function start void and do while true. I guess we could do that. Right, let's do this first and see if this builds at least. So we want to go to kernel and we want to do zig build. And that's pretty much all we want to do. Okay. So no errors, but let's see. So zig out, I guess bin. Okay, so we do have a kernel 64 there. So lvm objdump dash d dash mintal and zig out bin kernel 64. Right. So I guess this is using the debug symbols. So let's just go all the way up there. Okay, so we do have our start, we push, move. Okay, I want to get rid of this push and move thing here, but this jumps to the next instruction, and the next instruction is the infinite loop. Cool. Okay, cool. I'll just do something else before we move on. I'll do d optimize equals release fast. Does that work? Yes, it does, I guess. No, hold on, let me just clear this and redump so that I can do this and go up there. Cool, so this optimized our code to just have the jump in it. Right, cool. So let me go back to building without the optimized flag. Just have the debug version of our code, and I want to make sure I get rid of this push move and stuff like that. And I think that's what they call conv. And I want this to be, so what are our choices here? I want this to be none, no convention, just the naked function itself. Naked. Right, let's try that. Right, so build, clear, and redump that. And there we have it. So now we know that naked is basically doesn't generate the function prelude for us. Right, now what I want to do is do pub function kernel main. I guess call conv would still be naked. Oops, and void. And I want to also have this function just call the other one. So kernel main. And I've also seen while perusing the Zig documentation that we have, we have a no return return type, which basically is the type of unreachable. So I think, and from this example here, so I've basically taken inspiration from this example here. They have set no return as the return type of this exit process. So I want to also do that here because I want to make sure that we are not returning from this function here. Just want to see what Zig would generate. So function declared unable to call function with call-in convention naked. Huh. Okay. Why? Does it need to be export? No. Well, do I have to get rid of this? Runtime call not allowed in naked function. Okay, so call conf. Okay, what are you expecting from? Let's do this. Volatile, just so that it doesn't rearrange stuff. And can we do call kernel main? Is that something we can do? Undefined symbol kernel main. Okay. Can we declare a global, or do we need to export it? Okay, it's happy with that. It's happy with that. Right. Let's see here. So it's calling kernel main, which is this here. And kernel main is not doing anything, which is why it's and I guess UD2 is undefined. So I guess this instruction is here to trigger a hardware exception. And is that linked to the fact that we said we want this to have no return though? If I change this to void, clear first, and then no. So it generates UD2 in case we are leaving the thing. Huh. Okay. So I guess we'd still like to have a while true statement there. Leave the no return there, just for our own semantic and here we have an infinite loop there, and here we have the call to this address here, which is our kernel main. Okay, cool. So what did we learn? We learned that we cannot call a naked function by just calling it normally. We have to emit the call instruction in assembly. We have learned that, well, that's all we've learned, I guess. Right, so now I want to do something else because I've read the documentation, and so let me go to ASM. Inline assembly, and so where was it? It was hidden somewhere. Oh, there we go. So global assembly, this one piqued my interest. So we can have a global assembly just floating inside a module. So here they have a global myfunc. So they're defining this function here. They are defining its type as a function, and they are basically giving it a body. And here they are just exporting it as an extern, or rather importing it as an extern from this assembly block. Right. So let's try to use that. So comp time ASM. Oops. No, there we go. So is there volatile? So volatile is not valid because all global assemblies unconditionally included. Okay, cool. Good to know. And here we should have something like global kernel main and call kernel main. And here I guess we could just remove that and regenerate our code. Okay. Cannot find entry symbol start. Huh. Right, so we are going to need to tell that this is start. Start. How about that? No. Should I declare it here? Global start. Okay, it's happy with that. So start is call kernel main, and it still works. Cool. So this is pretty cool. Now I wonder what happens if we do this. No, if we do this. And I want to also just add the, what should we do here? Okay, I have an idea. So const or var, I don't know. So const boot info, and this would be, or is it extern? Const boot info of type a pointer to U64. That's all I'm willing to say for now. And this, I guess I'll define it as extern, since I have it in my linker script, boot info. There we go. And I'll go over here and do while true. Something like boot info equal or plus equals 1. It's gonna complain that this is constant, but here I should do boot info dereference stat and plus equal 1 to 3, for example. Okay. Okay, so expected found what? Comp time of int. Right, okay. Right, so var index is 0 and index is U64. And there's an equal sign there. And here I'll do index plus equals 1, and this I'll change to a multi thingy of thingy. Right, so this would be index, and I'll just do that. How about now? Okay. Local variable in naked function. Right. Right. How about now? No. Oh, sorry. Yeah, it's built. It built. It did build. Right, so let's go all the way up here. So we are calling into our kernel main. So this would still, so the start still got exported first as our entry point. Cool. And now in our kernel main, we have, so we have our prelude back because we've set call conv to C so that we can have variables on the stack. So here we are allocating our index, and here we are moving so we are setting 0 on our variable we've created, and we are moving that to RCX. Then we are moving RIP plus whatever this is to RAX. I guess this is this value here, which is env plus 2000 hex. And if we scroll down, can we find that value somewhere? Env. There we go. Yeah. So 3000. So this one looks like, so FC and 3 pairs of zeros. That looks like what we have here. So FC and 3 pairs of zeros. Cool. So that's exactly what we wanted. So we are moving into RIX the value of boot info. Then we are dereferencing boot info. We are moving RCX into RSI. We are shifting it left by 3. What? Okay. And we are moving RDX. So, okay, so this is debug. There are a lot of instructions that can just be coalesced there. And we go around again. Oh, right. So all these instructions is just for this, so that we can do RX plus 8 times RCX, which is basically we index into RX with the index value that we have times the size of one entry, which is U64, 8 bytes. And we add 0x7b, which is 1 to 3. And we move it back to there. I guess this is superfluous again. But okay, that's fine. And some debug stuff that's been generated by Zig that we don't need, but okay. Right. Yeah, okay. So that's actually pretty good. One last thing I want to do is, can we actually do kernel main like this? And I want to pass it on to, and this would take A, which is a U32, for example. And we are going to actually change this to A. and int cast, I guess. This is one of the things that I kind of hate about Zig. Ints do not cast up, which is weird. Okay, so runtime call not allowed in naked function. Right. So I guess we are out of luck. Let's do this first. Let's comment this out. I just want to see how the arguments get passed. Function explicitly returns. Okay. So while true, that's actually pretty good. It's I'm actually pretty happy that the compiler catches those things. Okay. Right, let me just get rid of that for now. Do this, do an int cast there for A, and I just want this to build. Right, kernel dump that. So here we are moving this to EDI, and we are calling main from EDI. Okay, cool. So let's add a few more variables. So let's do B U32, C U32, and D U32. What's the... oh yeah, they're not used. So plus B plus C plus D, I guess. Build that, clear, and dump. Right, so EDI, ESI, EDX, ECX. So we are on a register parameter passing. Right, and here we push them on the stack. For some reason. Actually, let me check something. I want to check that if I do optimize release fast, that I will just use them right out of the registers. Yes, okay, cool. That's more like it. Right, so let me just rebuild without that, clear, and redump that. Okay, so now that we know that we pass them through the registers, I want to go back to build.zig, and if I go here and do, for example, GNU ABI, okay, let's clear first and then do, and here we have basically the same thing happening again. Okay, so I guess it doesn't really matter whether we are in non-ABI. I guess if I do something like Microsoft, they do have a slightly different parameter passing ABI. But we'll see. Clear, redump that, please. Thank you. No, so it's still the same. Okay. Pretty weird, but okay. Let's go back to none, I guess. Cool. Well, I guess we do have a pretty solid starting point here for our kernel. Yeah, well, that's all for this one. Hope you've liked it. In parallel, I'm doing quite a bit of research on the kernel topics I want to cover. So these videos are a basically look into sort of research I do. Well, other than reading documentation, I'm not gonna read documentation on video. There are other people who do it a lot better than I will. So yeah, you might want to look into those if that's your thing. As for me, I'm just gonna keep reading code on video and documentation offline. That's pretty much it for today. So as always, like, subscribe, all the good stuff. I'll see you next time. Fucking out.